Okay, can you hear me? Yes. Okay, so good afternoon. My name is Shady Attia from Liège University, together with Professor Dirk Franco from Hasselt University. We are both together sharing this session. Well, before starting, I remind you to turn off your microphone and use the chat text box on the right side for questions and comments. We have 5 presentations today in this session. Each speaker has 10 minutes, so I urge speakers to respect this time limit. The session will be recorded, and at the end of the 5 presentations, around 14:50, we will have 25 minutes for Q&A. For now, I would like to present the first presenter of today's session. The title of the presentation is Assessment of the Circularity and Carbon Neutrality of an Office Building, the case of Het Centrum in Westerlo, Belgium. And the presenter is Mr. Muheeb Al-Obaidy. Mr. Muheeb Al-Obaidy is an architect graduated from the University of Technology in Baghdad, and he is currently an architect at Trias Architects and a PhD student enrolled at Liège University under the supervision of Professor Shady. That's it for the presentation of this session. I will terminate sharing the first 3 presentations, and then Professor Franco will take over with the presentation 4 and 5, and finally the Q&A session. I wish you are enjoying this presentation. Thank you very much. Muheeb, Mr. Muheeb, you can start. You can start sharing your presentation.
Thank you, Prof. Shady Attia. It's my paper title is Assessment of the Circularity and the Carbon Neutrality of an Office Building, the case of Centrum in Westerlo, Belgium. This building is designed to last for 20 years, and it's designed, constructed, and operated within an experimental setting that allowed the buildings dismantling and reconstruction every 5 years. We can see in this figure the concept of its centrum project. The building divided into 4 units, A, B, C, and D. All these units will be built one by one. The project will start with unit A and B and ended with C and D by using the material, the old material of the previous units A and B. So this study will answer 3 main questions. How can we evaluate the circularity of the building? What is the most sustainable structure system regarding carbon neutrality and circularity? And to what extent is its centrum project circular and carbon neutral? The methodology of the study, the case studies evaluation focused mainly on the building structure during the phase of construction, operation, and demolition. The parametric analysis took place for 2 different construction systems. We have the original system, original design, the timber and the steel proposed construction system. The analysis process was performed in 2 steps. First step, perform a detailed life cycle assessment for the environmental impact of the 2 structural materials, focusing on their carbon emissions. And the second step, performed parametric analysis for the project construction system and also for the other different construction system. In this figure, we can see the weight share of the material for 2 types of the structural material percentage after the inventory and using the material percentage. And the life cycle assessment has been done by use of one-click LCA according to life cycle assessment standards. This figure shows the visualization of the construction system and details for the original design of its centrum project. And here we can see the different construction system. This is proposed construction system, steel structure with the details. The results. According to this figure, the study remarked that the timber structure is superior to the steel structure in terms of achieving circularity and reducing carbon emissions. The study showed that carbon emissions in the timber structure are 5 times less than those in the steel structure during the product stage. According to this figure shows that during the life cycle of the whole building, witnessed a big difference in carbon emissions between the use of timber structure and the steel structure. It's up to 10 times less in the timber structure in 5-year scenario, the original scenario of CAMSI, and up to 8 times less in the 20 years scenario. So the biogenic carbon storage had made the building designed with the timber structure is considered to be a mostly negative impact in the terms of carbon emissions, unlike the steel. In this figure shows the circularity criteria. This criteria has been used in this study, and this criteria I developed them in my second paper, design criteria of circular building. The evaluation of the different construction for this project based on these 4 criteria. We have the carbon footprint. It's based on the life cycle assessment standards, and we use the one-click life cycle assessment software. And we have the reused content. It's according to the material inventory and the material percentage. And the assembly potential, it's based on the drawings and all information about the project, the building elements, and the structure details and the connections. And the end, the criteria number 4 is the design for flexibility, to check the ability to change the function of the building within a different scenario. And we can see the values here as shown. The disassembly potential and flexibility is the same for the 2 different structures, the steel and timber. And we can see also the difference between the footprint and reused material between them. Conclusions. The use of timber structure system in the building is considered one of the best material in the short and long time. It achieves a more significant benefit by combining circularity and achieving the desired goal of reducing carbon emissions. Timber can make the building have a negative environmental impact, and the research recommends designers address the 4 circularity principles presented in this study to assess future buildings: the carbon footprint, reuse content, disassembly potential, and flexibility and adaptability design. In the end, the life cycle assessments used in early design stage is not enough to inform the design decision making to achieve circularity. And I invite you to read my paper. And thank you very much.
Thank you very much, Mr. Muheeb. Very interesting presentation. Well, we will proceed We are in a parallel session number 3, co-shared by Professor Franco and Professor Attia. And the following presentation, presentation number 2, is entitled Understanding the Design Process and the Impact of Reversible Design Tools and Strategies Through Timeline Development. The presenter is Margaux Lespagnard. And Margaux is an architectural engineer. She graduated from the VUB. I invite her to share her PowerPoint presentation. And she is currently a PhD student at VUB under Professor Timmerman and Professor Gallet. Margaux, the floor is yours. We cannot hear you. Can you? I will have to unmute you, maybe, or maybe you unmute yourself. Yes. Here you go. Click on it. It doesn't work. Funny. Here you go. Perfect.
Yes. Okay. Can you see my presentation when I do show you like this?
Yes, now it's in a full mode. Perfect.
Okay, perfect. So hi, everyone. Thank you for the introduction. So I will explain to you how we try to understand the design process through timeline development. So it's not a new thing to you that our current take, make, waste models are quite a big environmental problem in this world today. 15 million tons of building waste are produced in Belgium alone, and this can already this number could already be minimized if architects were taking into account the future of the buildings they are designing today. And so researchers have developed quite a lot of tools over the past few decades, I'd say. But these are tools that could support architects when they are designing a building, so it will have a lower environmental impact. However, today there are so many tools that architects just start to get confused and wonder which tools should I use and when should I use it. And so we tried to think of how can we answer this question, and we thought to do this by first really understanding how a design process works. So how are decisions made, who and what influences these decisions? And then we thought if we could answer these questions first, we could make a better match between tools and the design process. And so we tried to answer these through a timeline concept where we would depict a design process in a linear way. Starting from the first design to execution and maybe even beyond. And we thought if we understand this timeline and this design process good enough, we could say, for example, at this moment in the design process, you could have a large impact by using tool A. And then maybe later in the design process, when you're making different types of decisions, you could use tool B and then maybe again tool A or tool C, D, you name it. And so to see what we could do with this concept, we chose 3 case studies. These were post-war high-rise renovations that all used the same renovation strategy, and that way we could compare the case studies. We organized an interview with each project architect of the case studies, and they also provided us with documents. And with this information, we could then start kind of constructing how the design process went on. And so we started developing timelines to really structure how decisions were made and so on. And then in these timelines, we could then identify key phases where a certain tool would have the largest impact. Then we did a second interview with the architects where we showed them the timelines that we had built and to see whether we maybe had some over or underestimations that we maybe understood wrong. And so with that information, we went back to our timelines and changed them a little bit. So a limitation of this method, though, is that we built the timelines after the design process was already finished. So the information we had was quite subjective because the architects, because it was based on the recollection of the architects, but still it gives a good idea of which decisions are most important in the design process, and it also really helped us to build this method. So let's build some timelines together. We start off with a grid, and on the horizontal axis we can see design phases. These are progress-based, and not necessarily based on exact time periods. These were the conceptual design phase, the developed design phase, the detailed design phase, and the execution phase. And they were based on literature from the British RIBA plan of work, because they they give a wide variety of projects onto which you can apply these design phases. Then on the vertical axis, we chose design aspects. These aspects can be chosen depending on which information you want to get from the timelines. In this case, we chose the function of the renovation, the structural design of the part of their renovation strategy, the materials going from structural materials all the way to detailed materials, the inhabited construction, which was something that was very specific to these case studies, where several case studies made their strategy in such a way that people could keep on living in the building while the renovation was going on. And then we also chose techniques to give like a bigger picture of how the design process worked. Then each aspect gets its own timeline, and the timelines become thicker depending on how much research or work the architects put into that aspect in that moment in time. So, for example, in the conceptual design phase, at one moment, there was a lot of research put into the function. Then we indicated decision moments. These are punctual moments where a certain decision is made, and they are usually preceded by a thickening timeline showing the research that was done to see which decisions there were, and then a decreasing timeline to start applying the decisions. Then you can connect certain elements in the timelines or certain decisions, and you can start to see the internal influences that are happening between the different aspects. And you can also, there were also parts of the timelines that were hatched, because these were places where two aspects were continuously influencing each other. So the timeline we just built together was for one of the projects we studied, where you can see that in the structural design for the structural design aspect and the material, there were two main big decisions that they made, and this was because they had they only did the building analysis at the end of the design process, so in the execution phase, and they saw that what they had designed did not work, and so they had to redesign actually part of their structure, and that's why you see here. If you compare this to another case study where the building analysis was done at the beginning of the design process, you can see that many decisions were made in the beginning, so at the conceptual design phase, and they were merely just worked out during the rest of the process. But regardless of these differences, there were also a lot of similarities that we saw, and especially when we started overlapping these timelines. And these similarities were actually pushing us to define key phases. So the first key phase we defined was for the functional aspect in the conceptual design phase, because defining your function here and getting a good functional concept can really influence the rest of your design process. So we connected that first key phase to scenario planning, where you explore different futures of your building and make sure that your building can adapt to it in the future. Then the second, sorry, I don't know if you could see that. The second this key phase we defined was the developed design phase for structural design and materials. We took these two aspects together because they are continuously influencing each other. So we connected this to a life cycle assessment, where you can calculate environmental impact of your building, but we have to specify that it was a simplified life cycle assessment because architects don't really have the time to to do a full life cycle assessment. And then the third key phase was the detailed design phase for materials, which we connected to circular design guidelines that give you advice on, for example, reversibility, using durable materials, and so on. So this is merely just part of the information that we got from these timelines, because with the timelines, you really have to analyze your design process very deeply. And you can also know other stuff like the influence of the actors, the influence of the budget, what the influence of certain information received at a certain moment in time. But I think the most important benefit of using the timeline development method is really the way you can communicate with building designers and maybe even other stakeholders in the design process. You can clearly show them, like, this is how you work, because this is often a very intuitive process for them. But if you start showing it visually on a timeline, they also get these insights. And if you then tell them, like, at this moment, if you use this certain tool, you could really make an impact, it can also really convince them to use that tool in the future. Thank you.
Thank you very much, Margaux. Well, I invite all attendees to share their comments and their questions in the chat box. And don't forget that we will have a Q&A session at the end. So don't hesitate to note your questions or post them for Margaux. I have to proceed with the third presentation of today. The third presentation titled is Circular Building with Raw Earth, a Qualitative Assessment. We are still in the parallel session number 3 with Erik Pelicaen. Erik Pelicaen is an architectural engineer. He graduated from the VUB, and he is currently a PhD student under the Professor Knappen in Hasselt. Erik, are you going to present your work, or I just turn on the PowerPoint that I received? You are muted, so just if you can click on the left side with the people, there is on the left side 20% or and then you have to touch yourself on the microphone. I lost him now. I cannot unmute myself, so I will do my best and I will try sharing what I have. Okay, you're fine with that?
Hello?
Yes, I can hear you. Perfect.
Okay, yes, I had to refresh the page because I was clicking on the microphone, but it didn't do anything. But okay. So for the people who do not know, I got a positive result from COVID yesterday, so I'm a bit ill. But I took a painkiller, so I will still be able to present, I think.
The floor is yours. Keep in mind that we are now 9 minutes. We are 1 minute short. So a bit of pressure to respect the timeline. And best of luck.
Okay, I will share my screen.
Perfect.
Are you seeing my first slide?
Very good. Full mode. Very good. Good luck.
Okay, so I would like to present to you my paper about circular building with raw earth, a qualitative assessment of 2 cases in Belgium. So we're all here because the main theme of this conference is about how to deal with this problem. And I think we can all agree that we have created a building tradition that is impossible for our planet to sustain. And since we have no planet B, we may need to rethink our building culture and look for alternative building materials. And while we are building the way we are, we're actually systematically digging away and disposing of a material that we often consider as waste, and that material is earth. Raw, pure, unbaked earth was almost forgotten as a building material in our regions, but it has resurfaced as a regenerative building material. In fact, we can see 2 emerging trends in the building sector today. On the one hand, there's an increasing demand to treat high-impact building materials in a circular way. And on the other hand, there's an increasing interest for regenerative building materials such as raw earth. And this means that the need for innovative circular applications with earth can grow in the near future. However, little is known about how to design and build with this material in a circular context. So first, we need to understand what can be the role and the potential of raw earth in the circular built environment. And therefore, the aim of this research was to fill this gap by assessing the circularity of earth architecture. And to do this, we analyzed two contemporary cases in Belgium using two different earthen construction techniques. The bio-class on the left was built with load-bearing compressed earth blocks, and the B-hall on the right was built with load-bearing rammed earth walls. And to assess the circularity of these buildings, triangulation was done between literature, interviews, and the analysis of technical documents. So literature about both fields was reviewed to make a theoretical assessment, and this was then verified and complemented by a practical assessment. But how do you assess the circularity of a particular building material? Well, as usual, we need a framework for that. However, the problem is here that the existing qualitative frameworks, such as this one, do not question the circularity of the resources used. So therefore, to tailor this framework to a specific building material, the suburb scale was removed here, and the material scale was added, keeping the same levels of assessment, that is the components, interfaces, and composition. So now we have a qualitative circular assessment matrix considering circular principles at the material scale as well. So for the full assessment of the two cases, I invite you to read my paper, but for now, I would like to give you more general findings and insights resulting from this triangulation analysis. And resulting from these findings, it appeared that the highest potential of Earth was at the material scale. So first, Earth is a non-renewable resource, or at least not rapidly renewable, but it is abundant and the components are often locally available. Second, raw earth proves to be a non-toxic, degradable, pure, and low-impact building material. And third, a great opportunity is the recovery of excavation soil from building sites to manufacture earthen building materials. However, it is very important that no stabilizers such as cement are used, because stabilizers are often added to improve durability or strength, but this comes at the cost of all these circular qualities at once. Then at the building element scale, so in this case, the earthen walls, I have a few important remarks to make. First thing to say is that there are a lot of misconceptions about the durability of earthen buildings. So for me, it's important to say that one, that there is enough empirical evidence of earthen buildings that have lasted for centuries. A second thing is that the maintenance of earthen buildings largely depends on the exposure to the weather and on the application of the right design principles. And three is that we're sometimes forced to stabilize earth to pass the existing durability tests, which are not adapted to earthen building materials. And this also comes at the cost of circular qualities. Another remark is that there's also potential in the simplicity of earthen buildings, as these techniques are generally very low tech. And also, in the case of rammed earth, recent developments in prefabrication techniques show great potential as well. And finally, another great opportunity lies in the reversibility of earthen buildings. And at the building scale, this reversibility is also related to the reusability of building components. But this is quite different from circular building as we know it. And to explain this, let's consider a conventional brick building. At its end of life, the cement mortar, the gypsum, and usually the insulation foam are difficult to remove from the bricks. So it's easier to dump it somewhere and never speak of it again. And that's the reason why in circular building, we want to make these interfaces between building components reversible. But reversible connections are generally dry connections because in circular building, the wet joints, such as cement mortars or glues, are labeled as irreversible connections. But in the case of earth, this is different. A distinct quality of earth that no other building material has is its ability to plasticize by the addition of water. And this has three important consequences in terms of circularity. One is that, unlike any other building material, you can recycle earth an almost infinite amount of times just by adding water. A second thing is that unlike many other building materials, you can repair earthen building components using the same material. And a third thing is that you can reuse other building materials that are embedded or connected to earthen building components. And to illustrate these benefits, I want to refer to a recently finished project in Germany called the Alnatura Campus. And here they used prefabricated rammed earth components with embedded insulation and geothermal wall heating. So this means that if we add water to these components, on the one hand, the earth can be recycled, and on the other hand, the insulation and the wall heating can be reused. So while in the eyes of many, water is seen as the enemy of Earth, it may be considered as a friend from a circular perspective. And to conclude, it can be said that Earth architecture shows circular potential at different scales, and some circular principles really show opportunities, such as the recovery of urban excavation soils, the reversibility of earthen building components, and the reusability of other materials in earthen buildings. However, a very important remark to be made is that these circular qualities are only valid if earth is not stabilized with cement. And therefore, I would like to finish with this example. So here, instead of cement stabilization, the building was designed with the principle of calculated erosion. And this significantly reduces the weathering of the facade while retaining all these circular qualities of earth. So rather than desperately trying to change the properties of earth to make it look more like concrete or something, I think we must learn to design within its material-specific limits and to exploit its many circular qualities to make a sustainable transition in our building culture. Thank you.
Thank you very much, Erik, for the presentation. I will give the floor to Professor Dirk Franco. He will continue sharing the session from here.
Yeah, thank you very much, Shady, and welcome everyone indeed to this section, parallel section number 1.3. So we will continue now with two other presentations, and the first and the second one will be given by you, Shady. So I suppose that you will cut in between and that you will separate the two sessions, of course. So the first is dealing with the leadership of several European Union member states in building carbon footprint regulations and their role also in promoting circular building design. So please, the floor is yours.
Thank you, Professor Franco. Good afternoon. This paper is written with three other co-authors, Maria Santos and Muheeb Al-Obaidy and Miriam Baskar, and myself, Shady Attia. The title of the presentation is Leadership of EU Member States in Building Carbon Footprint Regulation and their role in promoting circular building design. There are aims to assist the major aim of this paper is to assist the European Commission in identifying policies that support the uptake of circular buildings and carbon neutral buildings, to increase overall building service life and ease the use of secondary materials to improve resource efficiency throughout the building life cycle. And in this context, the research question is simple. To what extent are carbon neutrality and circularity as concepts integrated into mandatory building regulation, and who are the EU leading countries in this regard? Definitely, this is an initial study, and it will be going on in the context of a PhD work of Mr. Muheeb Al-Obaidy. Well, what was the methodology that was used in this work? We followed a systematic literature review and expert interviews on building legislation with focus always keywords circularity and carbon neutrality. And we had a screening of 27 member state regulations.
Sorry, Shady, sorry to interrupt you, but I got several comments that we only see your first slide, and if you can put it in the presentation mode. Sorry to interrupt you, but there are a lot of questions about that. Sorry.
No problem. Is it now, can you see the presentation?
But maybe you can put it in a presentation mode, because now we see on the left all the slides and just one in the center. So if you put it on presentation, thank you. Sorry.
No problem. I will do that. I just need to reshare. I will go into another. I will use Adobe. And can you see it now in a full mode screen?
Yeah. It's perfect now. It's perfect now.
Okay, I will just go fast over. Again, so the paper title is Leadership of EU Member States in Building Carbon Footprint Regulation and Their Role in Promoting Circular Building Design. This paper is co-authored with Maria Santos, Muheeb Al-Obaidy, Mariam Basker, and myself, Shady. Well, the aim of this study was to assist the European Commission to identify the policies that support the uptake of circular building and carbon neutrality. And the research question was mainly to what extent are carbon neutrality and circularity concepts integrated in mandatory building regulation, and who are the leading countries in this regard? Well, the research methodology focused on a systematic review for existing regulations, and we screened 27 member states with a focus on Denmark, Finland, France, Netherlands, and Sweden as a result of our screening phase, because it popped out directly after the screening that those countries have already in place regulations that are requiring life cycle assessment, environmental code of declarations. They have mandatory requirements to increase the service life cycle, and definitely the procurement process is also part of it. We excluded the criteria related to the urban and territorial scale, and the principle of triangulation was used to validate our findings of this study. Well, what are the results of our study? Allow me to share with you the 5 leading countries according to our study. It's mainly number 1, Denmark, followed by Finland, Sweden, France, and the Netherlands. And in the coming slide, I will start to discuss with you why this. In fact, the regulation landscape, as you can see, I would like to start with Denmark, is advanced relatively with policies and tools that aim to waste reuse and material separation. For example, Copenhagen is one of the leading European capitals that achieved the lowest emissions per capita of 2.5 tons per capita. In second place, we can find Finland that advanced in decarbonizing design by balancing carbon emissions to sink and storage. They are really obsessed with the concept of building as a storage of CO2. Finland is promoting already a wood architecture and promoting a landscape design that is embedding the circular economy principle, urban metabolism, and sustainable financing of carbon neutrality. And Finland also succeeded to strengthen its local identities and cultural resilience through sustainable wood architecture. As you can see, there are some figures under Finland that are indicating that there are concrete measures. Coming in the third place, Sweden. Sweden has progressive climate legislation that supports the transition towards a carbon neutral Sweden by 2045, 5 years ahead of the European Union. And they are effective from January 2022. And Sweden aims to recycle 70% of the construction residues. And this is one of the most ambitious legislation that we found in our review. Moving to the fourth and the last 5th country, France is number 4. It has very interesting carbon footprint reduction legislation RE 2021 or RE 2021, even though it's still not published, but we got access to the current draft, which are very promising, and they have very interesting thresholds of 4 kilograms of CO2 operational emissions equivalent per square meter of construction. And they are also pushing to have a dynamic LCA approach into calculation. And finally, I move to the Netherlands that has already a mandatory requirement for implementing LCA for all newly built construction, and definitely they have an ambitious plan with the phasing out of natural gas, and some municipalities, based on personal initiatives, they are having circular green public procurement protocols that are already implemented in place. Well, coming to the conclusion of my presentation of today, I can say that I have some recommendations. The first recommendation is that EU member states must adopt measures to limit carbon emissions and the carbon incorporated in products based on the European standard EN 15978 and the levels framework that was published last year. Despite that it is not addressing aspects of circularity, it can be considered as a vehicle or a lever to make sure that on the European level there is an understanding of the different aspects of circularity, and it will be very beneficial if the level rating or the level framework can be translated into rating systems, local national rating system, or coupled to existing ones in relation to green public procurement and to circularity. Also, the use of wooden buildings as carbon sinks and storage is gaining more and more momentum in the 5 investigated countries, and carbon emissions from heating are already very low in Sweden, Denmark, and the Netherlands and Finland. So this approach of district heating and heat pumps use is promoting this idea of having a carbon neutral country. And I'm not talking about something that will happen. I'm talking about something that has already been happening since the year 2017 in most of the 5 investigated countries. Now moving to recommendation group 2, circularity criteria in general for buildings should be treated in isolation from carbon neutrality. Should not be, they should not be treated in isolation from carbon neutrality. From our review, we found them totally separated. In fact, the circularity criteria must be coupled to carbon footprint reduction measures. And as a consequence, timber construction materials and biosourced insulation material will be in great demand. The current supply chain of timber is already under pressure in Europe, and the availability of wood sourced from sustainably managed forests will not be enough to meet the European demand in the coming years. Moreover, the number of trained workers who can deliver timber construction projects is not sufficient across the EU, and the training of professionals, including architects, masons, electricians, plumbers, will require significant investment to prepare them to design and build timber construction. Coming to the last recommendation of my presentation of today, well, EU member states must increase the share of recycled and reused construction waste and the possibility of separating the materials for future reuse, and this has to be translated into the regulation. None of the investigated countries addressed this matter thoroughly, except Sweden. Timber and biosourced material will not cover the demand supply during the coming 20 years, therefore increasing the share of recycled and reused construction material and embedding thresholds and requirements in the existing legislation landscape will be very important. Some final closing remarks for the presentation of today. The European housing market is under pressure in Europe, and we need more and more housing units. There's already a good, clear housing supply gap in the European Union. What we will need to do with the pressure of stopping urbanization and the reuse of land is to have regulations that enforce and couple circularity and carbon neutrality paradigms in order to intensify the challenge of building sustainably. I invite you to read the paper. Thank you very much for your attention.
Thank you very much for this interesting overview of at least some member states in the European Union. Thank you very much for the interesting talk. Then we go on to the last presentation of this session 1.3, and it's also the colleague Shady Attia who will give the next presentation, and it will deal with design criteria for circular buildings. floor is yours again.
Thank you very much, Professor Franco. Can you see the presentation? Can you see the presentation?
It's okay. We can see it. Yeah, in presentation mode. Okay.
Okay. Good afternoon. The title of today's presentation is Design Criteria for Circular Buildings, and this paper is co-authored between Muheeb Al-Obaidy and myself, Shady. Well, as you can see, the presentation is based on 6 case studies that we worked on to distill criteria for circular buildings. The aim of this presentation is to aim the European Commission in identifying design criteria for circular building to increase overall building services and ease to use of secondary materials to improve the resource efficiency throughout the building life cycle. And the main research questions are: what are the design criteria for circular building designs that can be used in an initial design stage by architects, and how to take into account regeneration and impact recovery in those criteria? Well, the methodology is inspired by a previous publication by Kutafava that was published in 2020. I would invite you to have a look at the study. We did first a systematic literature review of the building circularity criteria. Then we created a pool of case studies and selected the most accessible case studies. And finally, we started to apply our own developed circularity audits with structured questionnaires for clients and designers of case studies. And finally, we came up with our set of criteria that we developed and validated so far. And again, I repeat, the study is still in an initial stage as part of a PhD's work of Mr. Muheeb Al-Obaidy. Well, what was this approach that we used in this study? We had simply a pool of case study that we used. We applied our circularity audits and structured interviews, and finally, we benefit from the synergies and validated that through visiting the building several times. Also, we based our criteria based on existing studies found in the literature. There is a previous book and previous work by Verdena and by Attia. We based our way to audit the buildings, check the connections, are they dry connections or soft chemical compounds, gluing, and so on. And we went through the different kind of fixations in order to make sure that the disassembly will be beneficial. And for sure, we consulted the literature that is available, that is developed in Belgium under the OVAM, the VUB lab, and other research units in TU Delft, for example. So this was a very extensive phase to check what was already there. And after that, we started to work on presenting the results. Before presenting the results, I just need to point out that we focused on the construction systems, the envelope system, the spatial function and use, and the building material and product services. Well, when it comes to the selected case study, as you can see, we have 5 case studies selected that are located, 4 case studies that are located in the Netherlands. Fokker 7.78 distribution center close to Schiphol Airport by Tata Steel. We have the head centrum building in Westerlo, Belgium. The green offices is exceptionally in Switzerland. And we have Iwan Social Housing in Nijmegen, the Netherlands. The circular pavilion, ABN AMRO in the Netherlands, Amsterdam, and the circular retrofit lab, VUB, Brussels, Belgium. Those are the 6 case studies that we investigated, and we managed to visit them, and we applied our audit sheet that we used in order to check our criteria. Now, when we looked at the major indicators that we can vulgarize or that we can characterize after doing the review phase and the visit stage, we came up with 4 major criteria, namely the carbon footprint. And in this sense, we did our calculations for a period of 50 years to look at the embodied and the operational carbon emitted over this period. We checked the reused content of the overall building material based on an inventory, and the bill and quantities were also helping. We checked what is the availability of virgin material, recycled material, reused material, and we even distinguished those 3 aspects from the salvaged materials. And every time we had a calculation based with a functional unit in kilogram of materials. The third criteria was focused on the disassembly potential and the longevity of the components. How can we disassemble the building? Are the fixations glued or bolted, nuts, and so on? And we went in all the connection types to make sure how can we dismantle the facade, how can we dismantle the foundation, how can we dismantle the structure, the skeleton, and so on. And finally, we went through building design flexibility and function adaptation by doing scenarios over periods of 50 to 100 years to change the use of the building and test different scenarios of use. So these are the four main criteria that we had. And here I am delighted to share with you these initial results. As you can see, this is the radar graph that we use so far. It is limited to the 4 indicators. The higher the number here, this means it's positive, and the more it's closer to the center, to the 0, it means it's a negative thing. So you can see that most buildings, they had a good carbon footprint assessment, meaning they have low carbon emission, if not neutral or even positive. This is due to sequestration and the use of timber. The disassembly potential, we were surprised, is very high in most of the used projects, but unfortunately, the reuse content was very low, and also the ability to adopt in the future to different uses was also low in most investigated projects. And as you can see, I would assume the centrum was one of the most interesting projects regarding the performance. Well, coming to the conclusion of today's presentation, in summary, we highly recommend using the 4 criteria above and translate them into universal building design indicators. We are already working with 2 architectural firms in Belgium, and they found our tool very beneficial. They used it, they tested, and they are already using it to inform the decision making and to exclude or include some design alternatives in their design process. So this is very interesting. Design teams and green public procurement authorities can select simple variables from those 4 indicators and develop sub-variables and measurement units and requirements that can be already integrated. And we should not claim that we invented the wheel. We just made it more simple, more clear, and more structured in relation and based on the literature that is existing and existing work of a lot of other researchers who developed indicators that are more calculated in a quantitative way. From there, it will be easy for government regulators and municipal authorities responsible for land use, urban planning, and building regulation to develop policies that can ensure products and materials remain in use as long as possible, using secondary materials and regenerating natural systems. From here, I invite you to read the paper, and I thank you for your attention. This was the presentation of today on the design criteria for circular building. Thank you very much. I'm looking forward for the questions.
Thank you very much. We went a little bit out of time, but we have still plenty of time for questions. In order to not forget in the end, I like to thank already now all the presenters, and the floor is now open for discussion. I saw some question in the chat, and maybe you can ask the questions by yourself, give a little bit explanation of your position, and then ask the question to the specific presentation. Okay. So the floor is open for discussion. Maybe I can, to gain some time, I can cite one question. It was the question for the first presentation, and I see the question in the chat, and it sounds like, why does timber have a better environmental impact even with longer use case scenarios? Wouldn't steel be more durable in the long term?
Yes, I think this is a question for me.
Yeah, indeed.
Yeah, okay. In this case, I'm talking regarding the carbon emission. during the life cycle of the whole building, there is a big difference in the carbon emissions between the use of temperature capture and steam. It's up to 8 times less in the 20 years scenario and 10 times in 5 years. And in this case, I made the life cycle assessment for 20 years, the limit of the study. Maybe when we extend this period for 50 or 100 years, we will see a difference. Now I'm talking about the carbon emissions and the durability. Maybe it will be different, and that's what I will do in my next study. Thank you.
Okay, thank you very much. And indeed, Mieke is mentioning that the participants cannot make their question in an oral way. So I cite another one, and I think it's a question for Erik. The question is, can you make a combination? But I think you already answered it during your talk, but maybe you can give us some more details. The question is it possible to make a combination of isolation in view of heating and cooling of buildings? And you see it in a lot of African countries and also in the Middle East. I think you mentioned already some combination, Erik, but maybe you can have give some more details or examples.
Can you hear me and see me?
Yeah. Okay. Both, yes.
Okay. Yes. Thank you for the question. And as you say, Dirk, there was one slide in which I showed a project called the Al Natura campus in Germany, which is designed by one of the the contractor was one of the pioneers in rammed earth building techniques, and so they use these prefabricated rammed earth components with integrated or embedded in these components. There was the geothermal wall heating and also an insulation layer with recycled glass granulates. So from a circular perspective, this offers a lot of possibilities for reuse. But what you're saying, that you see it in a lot of African and countries and in the Middle East, I'm not sure if you're referring to the circularity or the building physics or the bioclimatic design, because of course the story of Earth goes very well together with passive cooling and heating, as one of the plenary speakers, I think it was Marwa, showed a lot of beautiful examples from vernacular architecture where this was the case. So I hoped I answered your question. Okay, but you're muted, Dirk.
Thank you. I think otherwise we will see it in the chat if it was not a complete answer. But I have also one question. Can it help indeed to prevent heating in the cities in the type of building material?
Earth, yes, of course. Well, for passive cooling, earth is a very ideal material because of its high thermal inertia as well, and so this offers interesting opportunities for passive cooling. And also in this for this there are a lot of examples from vernacular architecture. That's, I think, why in Egypt, like in the presentation of Marwa, they chose for this material on the one hand because this was a material that was available, but on the other hand that it offers this this amazing possibility for passive cooling. Yeah.
Okay, thank you. So then we move on, and I think the next two questions are both for Shady. The first question is, what causes the big differences? Is it due to the energy performance of the building during use? And then we will go on with the next question after. So is it the energy performance of the building during the use that causes the big energy differences and other aspects?
I think this question is for me.
Okay.
Yeah. The big difference here is not in the energy performance of the building, but it's during the product stage, A1 to A3. That's why we see the big difference in the structure and the steel structure. Thank you.
Okay. Okay, then definitely the question of Lina is dedicated to Shady. Yeah, probably you can read it with me in the chat, so I do not have to repeat it, or so the floor is yours to give the answer, Shady.
In a brief response, the project we are investigating, since they are flagship projects and outstanding projects, their project delivery process is not design, bid, build, but it is design and build, which means that the contractor and the architects, they are together working from day one on all the project details, including the choice of structural system, envelope solution, and discussing very easily what are the potential of this assembly. So in the case of our project, when we started to do the analysis, architects were from the beginning straight ahead. Are we going to use a prefabricated concrete building or disassembled steel structure or a timber structure? And there was, we have developed our own audit system that has very clear and simple questions like, what is the structural skeleton? What will be the foundation type and fixation details? What will be the relation between the facade or the envelope and the skeleton? And we talked in this process, it's a very simple question, and architect, they grasp it. But as long the contractor and the architects, they are working from day on together. So it was simple.
Okay, thank you very much. As long as I can see, there are no longer questions in the chat, but maybe some questions are still coming. Well, I have, sorry, Margaux, you have also a question for another speaker? Yeah, because I have a question for you as well.
Yeah, actually, I saw that there was a question for me as well, so I was thinking maybe I could answer.
Yeah.
Oh yeah, but it's a question by you.
Yeah, it's a question by me, because I wanted to ask you. You take a lot of interaction with different stakeholders, but I was also it's also interesting for me if you look at other aspects like comfort, and if you are also looking at the participation of the users of the building, the several users, the visitors, the inhabitants, the facility managers, and so on.
Yeah, so in this study, the architects were taken as the main stakeholders that we looked at, because they are the ones that usually use the tools to design their building. But indeed, afterwards, one of the conclusions of the study was also that it could be interesting to look at the different stakeholders, interview them, and make timelines based on their experience in the design process, and from that, look at how they interact with the timelines of different stakeholders. If you see what I mean, to see like where are the differences, where could maybe another tool influence the perception of a user of the building. But also the users was a difficult, a difficult stakeholder to take into account with these case studies, because the 3 case studies were big apartment buildings. 2 of them were social housing units, and 1 was like from a big developer. So the users were not really in the picture, except for one case study where there was like, where the architects explained to the users how they were going to renovate their building, but it was just one-way communication. So I think indeed taking users into account is quite important, and it's also something that I'm taking on in the future, in my future research. But in this case, it was a bit outside of the scope in a certain way. Yeah.
Yeah, I understand, but I asked the question because when we look with our group at energy efficiency, we also look at different participants. So also not only the facility manager of the euros that can be saved, but also at the comfort and the several stages of using the building. So the visitors, the inhabitants, the students, the researchers, and so on. So and it gives some more helicopter view and insight. And acceptance of decisions.
Yes, indeed.
Yeah.
Communicating to users why you do a certain thing can really influence the way a building is perceived and used as well, especially for the future. Yeah.
Okay, thank you for your comments. Are there still other questions maybe that I've skipped in the chat? I don't think. So I don't see any questions in the chat or a new one or an unsolved one. So if this is not the case, in behalf of Shady and myself, I'd like to thank you all for your contribution, as it was as a speaker or in your comments or in the question. Thank you very much. We were lucky there were no technical problems, so we could be in time and we can exchange the information. Thanks all for the interesting presentations and the new contacts. And then I was told that I have to kick you out, all of them, to go to the lobby. And I hope that you can then have a good and interesting continuation of this interesting conference. Thank you all, and see you soon. Bye.
Thank you very much, Professor Franco. Bye.
Bye.